Alright, hello everyone. So in this video I will be obliterating more test tubes because I bought this chemical and I want to test its cross-linking properties as far as polymerization goes. So this is temporary lab. In fact, it is a kitchen. Well. Anyway, so and also I'm testing new camera because this one, well, it's not dead, it is very much working, but it has been through some shit, so yeah. Anyway, so this thing is a diol with methacrylate group attached on both ends. Hexanediol is used a lot in the industry, so I bought some because I want to try it. So previously I tried to synthesize polyethylene glycol, dimethacrylate, and I wasn't very successful. Yeah, so I was able to synthesize the polyethylene glycol very well, thank you very much, but the methacrylate, not sure about that. Or in other words, I ended up with tarry goo. So let's talk about the test tube destroying. Previously I used an experiment where I randomly sampled few settings of concentration, basically, of a potentially resin that I basically guessed would work well. But this time I want to do a little bit better experiment because I think that I am getting closer to a real resin formulation that is actually useful. So I came across a video from Nighthawk in Light which is talked about something like Tamagotchi arrays or something like that. Pretty sure it's not Tamagotchi, but some Japanese thing. It is basically a multi-variant experiment where you have like... Okay, so in practice the numbers could look like this. So in previous videos I tried to use 1 to 4% of TPO initiator concentration, and it was usable, let's say. But since this is something new, I still determined to do some random testing, and these tubes are basically result of that. You can see, well, it would help if my floor was level, probably, right? But what I found is that actually this concentration range is very bad, and it produces this kind of sample. And I have to use microgram concentration instead. Okay, well, let's get back to that later. I also tried the hexanediol dimethacrylate and actually realized that, well, this range of concentration works even better, or at least this concentration did not work at all as I would expect it to. Okay, let's start with the first problem. Micrograms. How am I going to measure micrograms? Okay, I have this scale, and well, I could theoretically make a solution and then dilute it and stuff, but look at this, okay? Okay, I did not expect that to happen, but still, anyway. So it is 417 or 419? Wait a second, what? So, about that. This is not going to work. So I came up with something like this. This is a head of a screw metric M3 DIN 7911. So this is absolutely tiny, and I'm going to use this as a spoon, and I basically grab on some material, and then I'm going to use something to like scrape it off from off top, and I will be using this as a precise measurement tool. It's absolutely ridiculous, it's retarded, I love it. Now there are still problems, like for example I did initial sample testing with like for example this is methyl methacrylate, great, but is it inhibited with hydroquinone? Is it combined with dimethyltoluidine still? I have no fucking idea. Can I test? Yes. Is it easy? No. So I basically got bottle new and did purifications, so you can see that this is ultra pure. With yellow though. I dried it with fucking calcium sulfate that I buy from store because I forgot that I don't have magnesium sulfate anymore. So anyway, so let's go back to this stuff. So I did workup on methyl methacrylate, and this is also stabilized. This is with methyl ester of hydroquinone. So what about that? Does the workup with sodium hydroxide work? I don't think so. Okay, fine. So what works? Apparently, you can remove it with activated charcoal. No, thank you. I mean, okay, I tried, but how am I going to test whether it works or not? But then I read a little bit more, and apparently you don't need to remove it. Like, it is stabilized, I guess it doesn't auto-polymerize, but it is not like inhibiting the polymerization initiated by normal ways. Maybe it can be removed by DCM extraction, because apparently DCM doesn't mix very well with hexanediol dimethacrylate. I have no idea. Now let's talk a little bit more theory about practice. So this is a new setup. Basically, I have glued this together very quickly. So I just pop in this tube into this thing. This is not touching LED, but it is very close. This way, kind of, sort of. Anyway, so that's this thing. Okay, so I've gathered everything I need. This is methyl methacrylate, hexanediol methacrylate. This is a solution of dimethyltoluidine and triethylamine, 50% in methyl methacrylate. This is TPO initiator. This is my super precise scoop. I've got some scales. I am missing one thing, test tubes. So here it is. And I will basically do this. Look, this is the initiator. Absolutely wonderful. Yeah, and it's all over the walls. Fuck me, right? Next time I will do better. Alright, not sure how about you, but I am quite curious about how this will perform. That was nearly 40 seconds. Holy shit! Now, because this experiment was a little bit rushed, I jumped over the table of settings, I guess, a little bit, but so let's go over that quickly. So this is the sample number column, and these samples are ordered as they are in lines. This is the column for initiator, number of spoons that I put into each tube. So 1 spoon, 2 spoons, 4 spoons. This is dimethyltoluidine. This is drops of the 50% solution. 1 drop equals to about 0.5% of concentration in each test tube. So this is 0.51 and 1.5%. Same goes for triethylamine. This is hexanediol dimethacrylate concentration in percent. So this is 70, 85, 100%. This is the result time. You can see the color of these samples. Also to note is that number 1 has the least amount of unpolymerized residue. All of the other samples have pretty much equal amount of unpolymerized residue. Now just so you have some reference for the color, this piece has polymerized in storage. It's pretty nice piece actually. So yeah, this is pretty much 99.999% transparent. Well, not really, but quite close actually. So I think that number 1 is quite close. Number 2 is a little bit more yellow, you can kinda see it in the back reflections. These are hopeless pretty much. And I think number 8 was like, what the fuck. Also for reference, here is equivalent of sample 1, but instead of TPO initiator I have used benzyl dimethyl ketal as the initiator, and these are very clear, but they are very slow to polymerize. So then let's talk a little bit about time, and this is pretty much self-explanatory. The shortest polymerization time was 8 seconds for sample number 3, which has highest hexanediol dimethacrylate concentration and lowest concentration of initiator, which is interesting. Then the next one is sample number 4. Now there is quite a big difference between color of these two samples, but sample number 2 is quite acceptable and it came at 18 seconds. These two samples I have marked because I have run out of hexanediol dimethacrylate that was cleaned from the inhibitor. At least, well, I tried to clean it from the inhibitor. I have no idea whether it was or not. But looking at the time, probably not really, so... Now, as I have mentioned, this table allows you to calculate the influence of each variable on the formulation as a whole. So for example, in DMT, you look up setting number 1, which is for here, here and here. You sum up the times of the polymerization, so this is here, here and here, and you write this down here, and you are basically looking for a trend. So this is the highest value, this is the lowest value, but the second lowest value is here. So there isn't any trend, and now ideally you would repeat this experiment, this whole experiment 5 times, so you have less noise basically. So right now difference is 10, with more experiments it could be like 5, so it would be less significant, but 10 is not the smallest number, even though it is sum of all 3 experiments, so it would be like 3 seconds per one sample. And it's telling me that if anything, the DMT is not like doing anything useful for us. Pretty much same thing goes for triethylamine. There is no clear trend, and somehow this is showing better values for higher concentrations, but yeah, I think this is a lot of noise here. Difference here is what, 7, which is about 2 seconds per sample. So yeah, still not quite the smallest difference. For hexanediol, there is a very clear trend. Difference here is 48. That's about 15 seconds per sample. Well, it is huge, it is not really surprising. I mean, it's cross-linking agent, obviously the more you use, the better. I was kinda hoping that I would be fine using like 20% each, because then I could formulate cheaper resins, I guess, but I guess that won't happen right now. What's really surprising is the TPO influence. You would expect that the more initiator you use, the better it will be, but actually the trend is down. So, like with hexanediol, you cannot go past 100%, but with TPO you can go all the way to the 0. Question is, where does the trend stop? And there will be definitely some number, because without TPO it doesn't do anything. So the graph could look like this, whereas 0 it could be somewhere here. So yeah, finding this number is very interesting. Then again, question is whether these two are influencing each other in any way, and maybe you would find out that like without triethylamine you could offset this like somewhat like this. So this table does not give you the full picture of what are you looking at, but it gives very useful pointers, I would say. So for future experiments it would be very nice to see if removing methylhydroquinone from this thing would produce different polymerization times. And I also would be quite interested to see how this would look with the 100% hexanediol dimethacrylate and DBMK, DMBK, whatever initiator. And of course, there are much more things to research. For example, fillers. Like, what if I ground this up, dissolve it in hexanediol, and polymerize that? Would it be cheaper? Probably. Maybe. If I would be able to dissolve it, that would be great. Now, how about modifying the stickiness of the resin? Like, how about dropping in some CA glue? Would that work? Also, you can look at using pigments and stuff like that. So there is definitely a lot of work to be done here still. But in any case, I want to try this resin fairly soon because this board is waiting for me. Because this is a part of the kitchen line, and I was like, you know what, I would like to have this made from solid wood. I have made this board from polyurethane resin that was very, very inappropriate to use on this kind of application. It was painful, it was like 5 layers, it took me almost a week. So yeah, before that I was using this thing, but this is like cheap varnish, and the pigment of this wood is not that great. Like the difference is like night and day. Like, now the thing I don't like about 3D printing resins, epoxy base at least, is that this one is the 3D printing resin, but look at what happens if I turn on the UV light. This one has fluorescence. That sucks. Like, if you use this like as a kind of varnish in the sunlight, it looks like shit. And the protection that this resin is offering me is insane. You could probably spill sulfuric acid on this and not much would happen. I'm not sure about that, but still. Main problem for now is that the hexanediol is expensive, rather expensive. It's not a huge deal, but if I could make like 50-50 mix that would polymerize in a reasonable time, I would be very happy, because that would allow me to optimize the cost, and I will also try to find good way to synthesize diol methacrylate.